Energy is the ability to do work or produce heat. Work is force acting over a distance. It can be classified as either potential or kinetic. Potential energy is energy due to position or composition. Chemical bonds hold energy, which would be referred to as potential energy. Different bonds have different amounts of energy. For example, a car parked at the top of a hill has potential energy. While sitting at the top, it has the ability to be converted into work when turned on and gas applied. Kinetic energy is energy due to motion. It depends on the mass and velocity of the object. Atoms and molecules have kinetic energy when they move. Consider the picture being drawn. A planet revolving around the sun has kinetic energy. Another example of kinetic energy would be a grocery cart being pushed around the store. Just as matter is conserved when a chemical reaction occurs, energy is conserved. And this is a very important characteristic of energy. The law of conservation of energy states that energy can neither be created nor destroyed, but it can be converted from one form to another. The energy of the universe is constant. This is also known as the first law of thermodynamics. Ball A has an initially higher position and therefore has more potential energy than ball B. When ball A is released, it moves down the hill and collides with ball B. The energy of A has decreased because its position was lowered. This energy cannot simply disappear, so where did it go? The potential energy is changed to kinetic energy as the ball rolls down the hill. Do you remember when we talked about the first law of thermodynamics? There's also a second law of thermodynamics that states that the entropy of the universe is always increasing. Entropy is designated by the letter S. Entropy is a function used to keep track of the natural tendency for the components of the universe to become disordered. Essentially, it's a measure of disorder and randomness. All processes that occur in the universe lead to a net increase in the disorder of the universe. As the universe runs, it is perpetually heading towards more disorder. We are diving, slowly but inevitably, toward total randomness. Some might call it the heat death of the universe. Eventually, many eons from now, all energy will be spread unvaryingly throughout the universe and everything will be at the same temperature. It will no longer be possible to do any more work. The universe will be dead, inert, expired, and motionless. But not to worry. It'll happen many eons from now.